Hello everyone, welcome back to Intrinsic Intelligence channel. Today we are going to discuss on a system design concept which is failure models, a spectrum of failure models, how it is categorized in a distributed system while we are considering various factors. So we'll quickly move on into the introduction of what is failure models. So a failure model can be anything. So in a distributed system, a failure can happen at any point of time. There could be a single point of failures, or there could be failures which is recoverable. When the system is resilient, we could see there are nodes which is responding quite a late than the expected SLAs. And a failure model can occur for a short term and as a long term. We will see the various types of failure model. One is fail stop, another is crash, another is omission, temporal, Byzantine. So from starting from fail stop is easy to deal with. So the complexity grows when it moves from the left to right, from fail stop to Byzantine. If handling Byzantine kind of errors will take more time. So what is fail stop? So in a distributed system, a node can halt permanently. The other nodes try to communicate with it, will detect it. So consider there are 1,000 nodes across different geolocations or availability zones, and one goes down. When the other nodes try to get information from that node and identifies it is not responding for quite a bit of time, and then it finds it is down. So other nodes will be able to find it, and it is easily recoverable once we are able to find the failure node. So what is crash? It is different. It is similar to fail stop, but you consider there is a failure in a of a node in a network, and the other nodes will are not able to find it, and the request goes to the node which is not served. In that case, the proper response will not be served back to the client application. So this is called crash. So the node stopped working, and it is not detectable by the distributed system. And even though we have alerting mechanisms and other observabilities, so the nodes which is stopped working and it is not detectable is a crash, and this will take more time than the previous one, we fail stop. Compared to fail stop, the crash will take more time to recover, and the distributed system can halt silently. So that is a risk we have in this type of failure. So we have saw fail stop, crash, and the next one is omission failures. Omission failures are two types. So if a node fails to respond to the incoming request, it is called send omission failure, and if a node fails to receive a request, it is called receive omission failure. The node is partially working, and whether it could not be able to serve all the requests, whether it could be send request or it could be receive request. So this is a categorization of omission failures, and this needs a triaging of why it occurs. So it will take more time compared to crash or fail stop kind of errors. Next is temporal failures. Temporal failures are like if if your request is received in the distributed system and a particular node responds in a quite a bit of delay, or or it could be correctness of the results, or it could be both. Sometimes it can give us the correct results. There could be a synchronization issue. So consider in case of sharding the data. So it has to, when the request comes in, it has to query all the nodes. If some nodes responses quite late, even though if it produces the right results, so if it not produced given back to the customer on time, it the application will be expecting it, and then the results will not be accurate. So temporal failures or node generates the correct results, but it could be late, and hence it will not be useful to the end user or end application. So temporal failures are little hard to identify. Byzantine failure. So this is a very hard failure which needs time to debug and come along and analyze the impact. So these kind of failures happen due to a software bug, or it could be a malicious entity who could have attacked it, or producing wrong results, or stopping in the midway, something like intermittent kind of issues. So this type of failure is most challenging type of failure to deal with. So we have in this session we have saw the spectrum of failure models. The first one is fail stop. The second is crash, third is omission failures, fourth is temporal failures, and five is Byzantine failures. These are the five types of failure models we should consider while we are designing a distributed system, and it is base for any system design principles to come up with. Thank you for watching this video. If you have anything else to discuss more on this topic, please do comment on this comment section. Thank you all for watching this video.